In this video, I'll introduce you to haloalkanes, which are going to undergo substitution reactions. I will talk about the properties of haloalkanes, naming them, and we'll talk about how they undergo substitution reactions. Okay, so as you know from earlier in the semester, haloalkanes possess polar bonds, right? So in this, no matter what X is, if it's a halogen, it's going to be more electronegative than carbon, right? So the carbon is going to be partially positively charged. You can see in each one of these maps that there's a blue region on the back side of the carbon atom, which is a region of low electron density, which means that the carbon has a partial positive charge in each one of these haloalkanes. You can see as you go from fluorine to chlorine to bromine to iodine, this bond gets longer. So I asked a question here, would you expect carbon to be nucleophilic or electrophilic? Well, carbon has a partial positive charge, so it desires electrons, it's electrophilic. So haloalkanes are very good electrophiles in substitution reactions, as we'll see. Before we get there, I want to briefly talk about how to name haloalkanes. Instead of fluorine, we call it fluoro in systematic naming. Instead of chlorine, chloro, bromine is bromo, iodine is iodo. So this molecule would be 2-chloropropane, and this would be 2-bromo, 2-methyl pentane. Also remember that in molecules that contain stereocenters, that we need to include the stereocenter configuration, RNS configuration, in the name. So in this case, this molecule would be named bromo trimethyl heptane, right? And the bromine is on carbon 5, and bromine gets priority 1, and this group gets priority 2, this group gets priority 3. So we're rotating around in the clockwise position, so this is the R configuration. So we call this compound R-5-bromo-2,3,3 trimethyl heptane. Remember to put the configuration in parentheses before at the very beginning of the name. What you're going to encounter oftentimes are common names for small haloalkanes. So while this compound would be called chloroethane, a lot of times in the common name we call this ethyl chloride. For example, this compound we just mentioned would be called, the IUPAC name would be 2-chloropropane, but since this is an isopropyl group, the common name for this would be isopropyl chloride. Similarly, this one would be called propyl bromide, and this compound is called methyl iodide. I'd like you to understand what these common names mean, but not necessarily, I'm not going to expect you to be able to produce them under quiz or exam settings. Haloalkanes undergo substitution reactions. They are good electrophiles in substitution reactions because these bonds are polarized. So this carbon is partially positively charged. The nucleophilic sulfur atom will be attracted. So let's introduce one more piece of terminology here. These halogens are going to leave in substitution reactions. So we call this the leaving group. So in this reaction, chloride is the leaving group. Isopropyl chloride is the electrophile, and the thiolate ion is the nucleophile. What we'll find in this chapter is that chloride, bromide, and iodide are common leaving groups. The reason is because these are the conjugate bases of strong acids, which means that these conjugate bases are very stable. Cl-, Br-, and I- are extremely stable. So they're okay with leaving. They're stable on this side of the equation. Okay, so if you had this particular reaction and we were asked to identify the nucleophile, electrophile, and a leaving group, what we would say is that this molecule, 1-bromobutane, is the electrophile. Let me erase that. This is the electrophile because this carbon has a partial positive charge. Hydroxide is the nucleophile. And bromide is the leaving group. Okay, so to summarize, you should know that haloalkanes possess polar bonds. We already know that. But because those bonds are polarized, that carbon bears a partial positive charge. Nucleophiles are attracted to that carbon and can form bonds there. So those polar bonds can undergo substitution reactions with nucleophiles. Know how to name haloalkanes and keep in mind that we call them fluoroalkanes, chloro, bromo, and iodoalkanes. And be aware of common names, although I'm not going to ask you to produce them. You might encounter these. Then also be able to identify nucleophiles and electrophiles, as we've already talked about, but also leaving groups, which are usually halogens in substitution reactions.